Buenas. Hey. Hi. How's everyone? Sorry about that Spanish. I wasn't paying attention. Um, so welcome to the second session of this Java Code Camp. And if you like to code, you are in the right place. So, this second session, we're going to be doing more refactoring. And in this particular session, we're going to be talking about how we can use the solid principles when we use when we do refactoring. And as always, we will be doing live coding, which is the thing that we like to do the most. So why don't we jump into the presentation, and we'll be speaking a little bit about the solid refactoring essentials. All right. So one of the best moments to do refactoring is when we have a piece of legacy code that needs to be modified in order to add new features, right? So sometimes it's hard to find the time to actually modify legacy code because usually if it is working, you don't want to touch it and you don't want to look at the actual you don't want to spend time fixing something that is still working. So you want to have a reason to actually modify it, and a good reason to do this is we have to sorry. So one of the reasons we want to do this is because we want to have some time to actually modify the code that we're working on. So if we have to find that time and the resources to work on code, uh, the best way to do it is when we have to add new features to it. And also, adding new features to the code will help you to adding new features to the code will help you justify the time because adding new features to code that is not good, it takes a lot of time. But if you can improve the code, then adding new features to it will be easy. So that's why we do this. And remember, if you haven't watched the last session, you can always watch the last session in the there is a link that we're going to be sending. We're going to share with you where you can watch the previous sessions. And the last session we talked about how we can create tests to refactor. In this new session, we're going to be using the solid principles to refactor. All right, so we were talking about doing this refactoring here, and what we want to do is we want to use the solid principles to guide us in the refactoring process. So why would we use the solid principles, and what are the solid principles? So the solid principles are those that that we follow in the design of good software. So when we're building good quality software, we always take into consideration these 5 principles that are the single responsibility principle, the open close principle, list scope substitution, interface segregation, and dependency inversion. All of them are just very nice ways to summarize good good quality software design principles that will help you create better code that will be easier to maintain, to work with, to refactor, etc. So we are going to be using these principles in our refactoring so that we can work together and we can refactor a code that has been done in an old-fashioned way and that didn't use these principles. And the reason we are going to do this is we have to add a new feature to this code. So I'm not going to talk about the principles right now because I'm going to introduce them as we are looking at the code. All right. And but what I will say is that we want to introduce our tutorial, and we want to add a new feature to this piece of software. So here's the tutorial. Here's what we're going to be working on. This is a is a is an example of a of code that can be seen in Martin Fowler's book Refactoring, and this code is available for all of us to take a look at, and we are going to use this code as a base for our tutorial. So if you're watching online and you want to follow along this tutorial, then you can take a look at the link, and I'm just checking if we send the link, and yes, we have the GitHub repository there. So the team from Globant has already shared with you uh, the GitHub repository, so you'll be able to follow along. I think, oh, the could be that the repository is empty, so I'm going to quickly share. I'm going to push this so that everyone can download this. So I think I moved it to a different repository, so now you should be able to see the code in the repository. And so download the code, clone that GitHub repository, and then we will also start working on this software. But let me tell you first what this does. This software is very simple. It's a software used by a theater that to pay to the actors that played a particular role in their plays. So we have some actors, for example, John and Mary, and they participate in different plays. For example, John plays, he plays in Hamlet, and he also plays in As You Like It. And Mary plays in Othello and in As You Like It. So, and they have multiple presentations. So they could have 2 presentations in Hamlet and 1 in As You Like It, and so on. So, and different presentations have different amount of audiences. So depending on how many audience was in that presentation, that performance, then they'll pay more or less. And also, depending on the type of the play, they will be paid more or less. So this type of play is a tragedy, so that pays with a different formula than this one, which is a comedy, right? So that is basically our tutorial. It's a very simple piece of software, but so what it does is it will calculate how much it has to pay to the different actors, and then it will print that into a text statement. But we don't want to print it just as a so we want to change the format. We don't want to print it as a text. We want to print it also as a JSON. So how do we do that? That's what we are going to do. We're going to refactor the code so that we can do that change, and then we can add the new functionality. All right. So I think we've solved the empty repository problem, but you can let us know if you still have that problem. But if not, let me show you what you'll find in this repository. So first thing we have in our repository is this class called the statement printer test. And in this class, we'll have a few tests that we can use to test our functionality. And so here's what I was telling you. This is the place that the theater works with, and here's an invoice with the audience and the play, and in here we send this invoice with the different performances, and we send it to this class, the statement printer, and this class will print the statement, and then we compare it with the expected statement. So we are expecting this result, and the same happens here. So in this case, we have 3 plays and we have 3 performances, 1 for each play. All right, and so we send it to the statement printer. The printer processes the invoice with the 3 plays, and finally it gives you a statement, and that statement will have many lines, 1 per play. Okay, so it's pretty easy to understand, but let's take a look at the actual code of the statement printer. Right, so the statement printer has one method, and this method is called print, which makes sense. It prints this statement. So let's see, what do we have here? All right, so we have, it receives an invoice, and let's take a look at the invoice class. And the invoice class has a customer, and it has the performances. So it has a list of all the performances, which, if we look at this, is the arrows in this diagram. So these arrows are different performances. So this guy, this is, let's say, John, and he performed 3 times, so he has 3 performances. So he sends an invoice to the theater saying, okay, you have to pay me for these 3 performances. Okay, and the performances, as we saw, they have the ID of the play that John did, for example, Hamlet, and then it also has the audience, so how many people actually attended to the performance. So we are going to see again here the code, and what we see is first the statement printer is going to calculate the different amounts that it's owed to the player, to the actor. And we'll see here we have the total amount, and it also calculates something called the credits. And then it goes through the different performances, and we fetch the performance from the performance database, let's call it. And then it will, for each performance, it will check the type of the play, the type of the actual play, and if it is a tragedy, it will do this, so which is the calculation. And then if it is a comedy, it will do this, right? Otherwise, it will throw an exception, an awful error. And then we have we are adding everything together. So we add all the different credits, and we also add the total amount. Okay, and we do something else. If it is comedy, we do something else, which is some volume credits that it's adding. So we can see already that a lot is going on in this method, right? This is not only printing. So if it is not only printing, then this method seems to be doing more than it actually says. Because I would say, okay, give me an invoice and it will print the statement, but it's actually also calculating the amounts. It is also fetching everything from the database. So there's a lot going on here. It's not just printing. And here's where we want to talk about the different solid principles and how this can help us refactor this code. Because now this, imagine here we are printing everything, but it's printing, you see here, here we are formatting everything into string. Okay, so we want to format things, but in different formats, not just string. We can create a JSON, we can create an XML, we can switch formats, because not every client will use the same format. Maybe there is one client that will use JSON, for example. So what we can see here is that if we want to change this to print in JSON, we would need to come here and say, for example, so in here we have the result, and in the result we would need to say something like if, let's say, print as JSON, let's say this is a boolean that we sent as parameter here. So we would say if print as JSON, then we would have to move this logic inside here and add it to the result. So we would actually move this whole line, for example, here, else, and we would say, so in here we would actually say format line as JSON. Let's say we can create a method here and send the line, which is the performance, and this would be and the amount that has accumulated. So this is really getting more and more complicated, because if we have a different format, we'll have to add a second parameter saying, for example, print as XML and so on. And that's not what we want, because we're having two different concerns being mixed in the same class. And what are those concerns? Let's go back in here. We can identify multiple concerns that this class is tackling and how this becomes a problem for the solid principles. Remember the solid principle, the first one, single responsibility principle. Okay, so single responsibility principle says that a class should have a single responsibility, and it shouldn't do more than that, because that makes the class more complex and harder to understand and harder to modify, harder to extend, and so on and so on. So we identified two responsibilities, and we could also say three, but let's stop with two first. The first responsibility is the class is calculating the different amounts for the statement. So basically it's doing the business logic of calculating how much we owe to this actor. On the other hand, the class is also formatting the output. So it's basically creating a an output in the text format, in the plain text format, and and the logic, and the worst part is that the logic for all this is mixed up. So we can see things that have to do with the calculation here, and for example it's also in here, but we can also see things in the middle that have to do with the actual formatting, for example here, and then here and here. So if we have those things in the middle, that means we're mixing concerns together. So the single responsibility principle, remember, it says that we shouldn't be doing this we should be having the class do one thing. If we want a class to calculate and produce the calculation, so the statement, we should create a class called, for example, the statement generator, and then we could have another class called the statement printer, which is this one really. So the statement printer would only print it in the text format, and then the statement generator will produce a statement. And what is the advantage of doing that? If we do it like that, then we would be able to create different statement printers. Because if we have a class that creates a statement, for example, one class creates it generates the whole statement as a Java object, and then we have multiple statement printers. We can have a JSON statement printer, we can have a text statement printer, we can have a XML statement printer, and so on. So that's a great advantage, and that is what by following the single responsibility principle, we can get that level of abstraction. I don't know if there are any questions so far. It seems like everything is going okay. I'm checking also if there are any questions, but it seems like everything is fine for now. All right. So the other thing that we need to bear in mind is that there are other principles, and the other principle that I can see in here that is not being followed is one called the open-closed principle. What would be a violation of the open-closed principle? There are two, basically. Remember I said I want to extend this so that I can have a JSON printer. I cannot do that. I would need to put the logic for JSON printing in here. So if I have to do this, that means I need to get in the middle of the code and start checking if it is if I want to print in JSON or if I want to print in text. So this is not easily able to extend. What and why do we say this violates the open-closed principle? Open-closed stands for a class should be open for extension and closed for modifications. So usually you don't want to modify your classes too much. You should be able to extend the behavior of your classes. So if you want to modify something, then you should have the proper interfaces so that you can extend that instead of modifying the classes. So for example, if you have an interface, by having an interface, you can create new implementations of that interface. So that would be in alignment with the open close principle, because it's saying, okay, you have this interface, you can create new implementations and you can switch different implementations, and that would be okay. So this class violates the open close principle in many ways. One of the ways is the different formats. For example, I cannot change the format. I had to modify the code a lot so that I can print this in JSON. Yeah, another way in which this violates that principle is the switch statement. This switch statement it forces me to put here a new case. So if I want to create a new type of play, let's say romance, I would need to have here the logic. So I would need to keep adding lines of code to this class, and that is probably a lot of lines of code for a single class. Not saying it's wrong to use switch statements, because sometimes they are good, but in many cases we can also modify this behavior, and we can segregate this interface by using a refactoring technique called replace conditionals with polymorphism. So what we would end up having is, what is this doing? This is calculating the amount that has to be paid depending on the different plays. So we could create an interface called the amount calculator, for example, or the play type calculator, and that will basically give us the ability to modify that interface. So we'll have an interface, and then we'll have different implementations, and we can have, for example, an implementation for tragedy, we could have an implementation for comedy, and if we need to add a new type of play in the future, we just add a new type of calculator, but we won't have to modify this class at all. We just need to add the new interface, and that's it. So that is why we want to follow the open close principle, because we want to have the ability to extend the behavior without modifying existing classes. Another way in which this is not following the principle of open close is on the access to the data. So this is accessing the data here, but maybe we can have a different layer for accessing the data. We won't be doing that refactoring, but and it's receiving the data as a parameter, so that is not as bad as, for example, if we would have the data here as a if we would have the data as a field, for example, and it's a map, and it's not a, let's say, an interface that we can access data, that would be better. That would be more ugly, let's say. But since it's receiving it as parameter, we could say that this data could have come from a database or a REST API or whatever. So it's not bad. Okay, so our objective is to refactor this so that we can add our new JSON statement, statement printer. So I'm going to start by changing the name of this. I'm going to say this is going to be simple text statement printer, and I'm just renaming it. Okay. And I have a test, so that means if I broke anything, I wouldn't be able to run this test. It wouldn't pass. So, but because it was a simple renaming, I know this is not going to cause any problems. after the renaming, we'll start looking for the different things that we can extract. So, all right, so we have this calculation here over here, and so this variable here, this amount, this is a counter basically. It's accumulator. It's an accumulator variable. So we should probably put this. Why is it accumulating? All right. It's set to 0 each time, right? And depending on the value, depending on the case, basically, it's returning a different amount. So what we'll do is to make it easy. This is basically saying the only output for this is the amount, right? Is this amount. So we're going to extract this. Remember, if we want to extract code, we do Option, Command, and M in Mac. And if you are in Windows, you would do Control, Alt, and M. And let's say calculate amount. Okay, so now we have at least extracted that piece of code, and we can go to our statement printer test and run the test and make sure that everything is still running. That should be the case. We just did a automatic refactoring, so we'll see. Uh-oh, I have something. I think something's wrong with IntelliJ. I need to restart it. Let me just close this project and reopen it again. Sorry. And let's open. And I'm going to put it here. Okay, so now it seems to be okay. Something was wrong with my IntelliJ. I see a question in the meantime. So it says, I've seen that the code doesn't define a variable type. That's a good practice in upper Java versions, or is that what we are trying to organize? Actually, I've seen it work both ways. Some people prefer to declare the type, some people don't, and I usually use this method of having the variables without type because it makes the code shorter, and you don't really usually with the new IDEs you don't really need to go to the declaration to know the type. If you step over the variable, for example, it would tell you that it's a string, or it will tell you that the variable is an integer, like this, like I'm doing here. So that shouldn't be a problem. All right, so now let's try and run the test again. But I promise this was running before. Okay, so everything's running now, right? So I did that refactoring for the in here for the calculation of the amount, and everything still runs as it was working. So now I'm going to I would still need to add, if we want to add a new type, I would still need to add it like this, and then do this with the amount and so on. So if I really want to do it, what I would need to do, if I want to make this follow the open closed principle, I would need to put this in an interface. So I'm going to do just that. Let's do it. And the idea in here would be, let's create this interface here, saying new Java class, and this would be called, let's just call it play type amount calculator. Okay, and it's going to be an interface. And by doing this in an interface, what we are trying to do as well is doing something called we're following the interface segregation, right? So we're trying to segregate different interfaces so that we don't have one interface that does everything. We can have multiple interfaces, and usually that's what we want. Okay, so let's implement this, and this interface will simply have this method. It will have a method, oops, like here, and we are going to put this method in our new interface. And now we can create implementations for this interface. So how do we do that? If we want to make it very quickly, we can do it with the IDE by clicking in Mac Option Enter, or in Windows Alt Enter, and it will prompt this, and you can say implement interface. And we can name our interface, for example, instead of play type, we'll replace play type, which is a generic term, with tragedy, which was one of the types. And in here it prompts the different methods that we want to implement. So this interface has only one method, so we'll implement it in here. And now it returns 0. So now we would need to go in here and basically copy this part. If we go to tragedy here, all right. So let's declare the variable, and this name is really bad, so we'll refactor this as well. Let's just call it amount, and we want to return that amount. Okay, and now also let's go back to the amount calculator and implement the interface a second time, but this time for comedy. And again, implement. We go to the statement printer and we copy this text here. So we have a new variable here, and we'll fix the name, leave it as amount, and let's return the amount. Fine, good. All right. Let's see. Okay, so now we can have our calculators in here. So we could have a map, and the key of the map will be the type of the play, and the value of the map will be the actual calculator. So for example, this would be play type, and we use the generic type here, the interface. And let's just call them amount calculators. And to create this map, we'll do it very quickly. And let's just say final private. Sorry, private. Final. And then here would say map off. And in here we'll have comedy. And this will be new comedy amount calculator and tragedy. And in here we would say new tragedy amount calculator. And we're good. Fine. So now we can replace this whole thing almost with our calculator map. So we're going to say this would be calculators. Sorry, this is static. I need to change it to non-static. And amount calculators, I can access it now. And let's just say get. And we'll have to access by the play type, because remember, the key is a play type. This will return a calculator, right? Let's just call it amount calculator. We could even not put it into a variable if we want. We'll do it later. And the amount calculator will say calculate amount, and we'll have to send the performance and the play and return. And this check here, we would need to check. If we don't have a calculator for this, we would need to say, for example, if amount calculator, if it is null, then we'll add this error. Let's just leave it as we have it for now. All right. So, and we can actually get rid of this variable. And you can see how easy this code becomes. Right. So now, if I run the tests, and if I go to the test class, I should be able to run this test and everything should work the same. Success. We've done it. So now we have our calculator interface, and you can see how easy that was. That was extremely easy, guys. And now you can also see how this code is starting to take shape, and we're seeing how actually things are starting to get separated. So what else? So what else can we do in order to improve this code? So we have separated the different the different calculators, and now we still have this thing that I don't like, the result, right? So the result is printing but the printing is done with, it uses the invoice, and it also uses the calculation here. So in here we have some more calculation, right? It's grabbing the amount and it's dividing it by 100 for some reason. Why is that? It's dividing currency instance. Right, this is probably because of a currency thing going on. And so this calculation here, we want to, so you see how the calculation, this calculation, we missed this. This should be in the calculator and not here. So we had to separate this because we are always doing this for formatting, but it's only for formatting, right? We're not using this for another thing. For the total amount, we still use this amount, right? So you can see how everything is being mixed up here. All right. So to fix this, and we are doing this formatting in the middle of the calculation, right? Because here we're calculating. So we'll have to move these calculations away. But before doing that, we also have this thing here we don't like. If comedy, then do this. All right, and if it is tragedy, what do we do? What if we have some other thing that we want to do in the future for tragedy? I think we should do the same that we did for the amounts, but in this case with calculators. So with the credits, right? So let's just at least put everything regarding credits. Let's just put it in. Let's extract this into a method, right? Enable. Why not? All right, I see that. It's adding to the credits. All right, so let's do this just to make it more visible. Let's say these credits, and this should be 0. So we should say these credits and in here these credits, and finally we would say volume credits plus equals this credits, okay, which is the same that we're doing with the amount in here. All right, so now we should be able to at least extract these credits. Right, so now we could say calculate credits. Again, we're getting rid of logic that we don't want in the printer. So let's move. Again, we could run the tests. Everything should be fine because there was an automated, almost automatic refactor. Let's just check just in case. We don't want to move a lot of pieces and then test. Let's move small pieces, test, small pieces, and test. Okay? Right, everything's working. So now we would just we could move this also in a different class. Reason being is that the calculation of the credits can vary by type. But for now, let's just leave it here. So we have the credits, we have the amounts, right? And still have this, which is bothering me. The result. So if we want to print this in different formats, the result shouldn't be a string, right? The result should be an object that can be turned into a string eventually. So we could create this object that we want we want the object to represent this statement, because in the end this string is a statement. Okay, so let's just create a new object in our model here, and we'll say statement. Good. So the statement, we'll see the statement will have a customer. So we could have this is a string. Okay, so we'll have in the statement we'll have a customer. Actually, let's use record. We'll see if we can use it, but if we can, let's use it. So this would be string customer. Then we'll use, what else do we have in the statement? Let's see. Where are we? Statement. Have the customer, and then we have one line per performance. Okay, if we look at the statement printer, sorry, at the output in the test, this one, we have the name of the client, and then we'll have the different performances, and then we have a total amount and a credits, right? So we will have, definitely will have the total amount and the credits. We could put it as part of the statement. So we could say int total amount int credits. And the other thing that I mentioned is the lines, right? So every line will have the name of the play, and also it has the value, the amount, and also the audience. So we could put that in the statement as well. So actually we'll need a list. We'll need a list of lines. So we could create a new class called statement line, right? I see there is another question which says, for more complex interfaces, do you use any tool to make it quicker? Or do you prefer to keep your interfaces as simple as you can? Always keep it as simple as you can. That definitely. I'm not sure which tools you're referring to, but I don't use any tools for creating interfaces other than my IDE. I just, whenever I identify an interface, I will just create it and then start creating the implementations. I don't know if you're referring to which kind of interface you're referring to. If you're referring to, let's say, REST interface or that kind of things, in those cases you do use tools, or you can use tools like Spring MVC, or you can use Jersey, but this is a different kind of interface I'm speaking about now. So yeah, just keep it simple. So we'll create this statement line in our model, and the statement line will represent, and I want it as a record, sorry. This statement line will represent a single line which is going to have an amount and a number of audience. I think that's all we have. So now we imported the list here, and so we should be able to start creating this this statement. So for example, in here, we want to put, let's just create here a new statement. Actually, no, I don't want this here. I want to create a new list of statement lines. Let's just do a new array list for now. Okay, so each line for each we'll just produce a statement line. So we'll say new statement line, and every statement line will have a amount, which is this amount, and it will also have the audience. So play oh, and also we'll have to add the play name, string play name. We could add the whole play if we want. And we can use all the data on the play if we want. So we would say play and this amount and performance dot audience. So now we have created a statement, and we can add it to our statement lines. So lines dot add. So we are adding here, and if we want to make this even shorter, we can get rid of this amount and put it in here. Okay, and we can also get rid of these credits, and we could just say adding to the accumulator like this. And the total amount is something that we'll calculate later. We don't really need it now. And we could or just to keep everything working for now, let's just put the statement into a variable. And we can use it in here. And we can use it in here. Just to keep everything working. So now we have statement lines. And let's just see if everything keeps running. Even though it doesn't make a lot of sense, this class for now, let's just test. And everything keeps working. Excellent. So let's move on. Now we have to move. So we have the statement line here. Let's just create the statement at the end. New statement. And the statement, we said it has this, the customer, he has the total amount, he has the credits, and he has the statement lines. Okay. That's brilliant. All right. So now we need to start. Now that we have a statement, we can reorganize the code in a way that everything that is regarding the statement is in somewhere, and everything that is not related to the statement is somewhere else. So how do we do that? If we can get rid of this line in here, we would have everything that is related to the statement in here, basically. But we just need to get rid of this line. So how do we do that? This line prints the result for each line. So what we could do is we'll have here, I'm going to be using a bit of functional programming. So we're going to, if you haven't watched the Java Code Camp on functional programming, you can watch it. That was our previous Code Camp, which was where we learn all the functional tools in Java. So I'm going to be using that at the moment to simplify this into, I will use the statement lines. Statement lines. And I'm going to be saying string and say map. So I'm going to be mapping the statement lines using the functor pattern that we learned, and we're going to be mapping a statement line into we're going to be mapping this statement line format. Wait, what just happened? I deleted something that I shouldn't have. Yeah, that was the problem. I'm going to do it here. So follow along now. We have statement line, string, then map, and we're going to map a statement line. Let's just call it SL using this. Okay. So remember we have for each the statement line has the play. Oh, sorry, it's called SL dot play, and then we have SL dot amount, and then we have SL dot audience, don't we? Statement line, do we have it in the statement lines, the audience? Yep. Maybe there is a spelling issue there. There, that was a problem. All right. So now we can do a join. And we can put everything into the result. So what we're doing here basically is we're transforming these lines into we're processing each line and we're turning it into a form. We're formatting it using the text formatting, right? But now if you can see, everything that is related to formatting is here, and everything related to statement is here. So we could move this and probably this, and we can see that everything that we actually need is in the statement. So the thing that we need to export at the end is the statement. So I can show you this by just saying, instead of calling the lines directly, I will call statement dot statement lines, and then the same is going to happen with these amounts. So statement dot amount, or total amount, and then statement dot credits. So now everything comes from the statement. So I don't really need these variables for processing, and I can show you this by running the test. And everything still runs, right? Oh, we have an error. What was the error? I think I added, yeah, I should remove this enter from here. That's the good thing about having tests. I had 2 enters added into my mapping. So now that I can remove it, let's see if it works. It could not work. Yeah. So I need that enter here, and I will join without using a delimiter. So that will make the trick. Then we'll have it working. Right, that's good, right? You saw what happens? This enter right here was being input twice, in the joining and in here. So because we didn't want, we are using it here, we don't want it here. And that's it. That's the good thing about having tests. We can play around and we're still sure that we haven't have a problem with our code. Right, so now we could have this into something called our statement generator. So we would say or generate statement. Okay, and again, this generate statement we can move this method into our into a new class. We could call it, for example, statement generator. And this class will basically have this method, these 2 methods. really. Let's go to our statement generator. And let's make this public. And also the calculate amount. So in our printer, we have the calculate amount method as well. So we'll put it away. And we'll put it in the statement generator as well. And also we had to move from the statement printer our calculators. So we go to statement generator and we have our calculators here in the top. And finally, we'll add a new field here, final, private final, statement generator. And we'll initialize it as a constructor, right? We initialize this in the constructor, and we will use this guy here. And also in our tests, now we'll have to go and fix the constructor. So we can say new statement generator, and the same in here. Okay. Now everything is working. So now you can see how small this code is. And this, you see also, everything is related to printing. This is all about formatting. So we have a class that we created by just moving code around and refactoring. And we have another class that only prints. So if I run this test now, everything should still work. You see? This is what we're doing by just applying solid principles. So what I'm going to do now is I'm going to create a package. So I'm going to say printers, right? And in this package, I'm going to move this printer here. So the printer, I guess the printer doesn't really need to know the invoice and the place, right? We could make the printer actually receive only a statement. So if we would say statement like that, and we could say statement customer, and we remove all this. So we can remove the statement generator again. And if we go to our test, let's go to our test. So let's remove the statement generator from the variable, and let's just put it outside. And we would call statement generator generate statement invoice and place, and we would pass this statement as a parameter here. Sorry, not here, in here, in the print method, right? So we can actually use this code in the other test that also has the same problems. And now everything is refactor. Okay, so you see what's going on here, right? So we have refactored the class in a way that the printer doesn't really need to know about the generation. It doesn't even generate anything. It's just a printer. So now if I run these tests, everything should be the same. And everything still works. Now let's move quick and I'm going to create in the printers package that I'm going to move my printer here. And I'm going to create a new interface, and it's going to be called statement printer. And it will have this method print. And now I'm going to create a new implementation. And I'm going to call this JSON statement printer. Okay? And the JSON statement printer is going to take advantage of a library called Jackson. So I'm going to be adding Jackson to our POM file. To add Jackson to our POM file, we are going to I have to look for the dependency. I'm looking for the dependency now. Where is it? Just bear with me, guys. And okay, I'm here. So we're in the POM file here, and we are adding, oops, we're going to add, oh, why isn't it not adding it? I'm trying to add a dependency here. There it is. So we are adding this dependency, and I'm going to copy this so that the team from Globant can put it in the chat as well. So this dependency will allow us to serialize the statement into a JSON file. So here's the test that we're going to do. Let's create a new test. For the JSON printer. Okay. And the cool thing that now that we have divided the printer from the generator is that we don't really need to test the actual generation of statements. We know it works. So we can do a printing without testing the generation. And that's the single responsibility principle in action. we don't have the responsibility to generate statements. So we don't need to create a statement from scratch. We can simply say new statement and add some stuff here, like for example, customer Mati. Then what else do we have in the statement? We have the total amount. Let's just say 1,000. We have the credits. Let's say 50, and we have the statement line. So we could say list of, and let's just add one. Let's just say the play should be new play. So first new statement line, and the statement line has a play and it has the amount, and it has the audience. Let's just say 40. Okay, and the play will have the name, which is Hamlet, and what else? It has a type, which is tragedy. Okay, so now we have a statement, and we don't have to test the whole generation of the statement because we have separated those concerns. And we trust that our class, the statement generator, was already tested. And it would be good to create separated tests for this eventually, so we can refactor our test, our original test, to test two things in separate. But let's go back to our test. We have this statement and we want to print it as a JSON. So we'll say statement new JSON statement printer, and we would say JSON statement printer dot print, and we'll send this statement, and this will return a string, JSON string statement. And what we'll do is we'll use object mapper which is a Jackson class, and we'll use this object mapper to read value, and we'll read this statement that we just generated as a string into the statement class. So Jackson can do that if it is a properly formatted JSON. We can do that. Actual statement, and we'll throw this exception for now, and then we'll say assert equals, for example, statement dot customer is actual statement dot customer, and then we could say we can compare something else. We could say, for example, statement total amount and the actual one, and they should match, right? And so that we can see that we have actually printed it, so that you believe me that we have printed this into a JSON. Let's just say JSON string statement, and this would be printed in the console output. So this won't work, right? It won't work because we haven't implemented this method. This method returns null, the print. So this will be in red. We will throw a null pointer exception. So we'll have to implement this. we'll use object mapper and we'll say write value as a string. And we'll transform this into string. And we'll surrender it with, yeah, and this is something that we'll have to refactor, but we'll just leave it for now as a runtime exception. Okay? So now, let's see if this works. This turns the statement into a JSON string. So this should work. It didn't. Right. The play class is making troubles now. So the problem here is that we don't have. Let's just put this as private. Wait, where is this being used? Let's turn this class into a record. Let's remove this from here. So this class is a record now. We don't need this constructor. And we are using the play in the statement generator. So we would say play type. Let's see if we have any other compile issues with that, but seems like we fixed it. There's one more. Name. So now we should see the JSON being generated in our test. We run this test and there are no more compile issues. It worked. So now the JSON was printed. So now we see that we have printed the same statement in JSON. And we can print the same statement if I say, for example, new text, simple text, and I generate the statement, simple text printer, print same statement, simple text print, and I put this in the system output as well. We'll have two statements, one in JSON and one in simple text. You see? Here's the JSON one with the play and everything, and here's the simple text one. That's the power of applying the solid principles when refactoring. How long did it take me to create the JSON version? Nothing, literally nothing. And to do it as a test, it took me nothing. I just had to refactor so that I could extend it quickly. And I could now create even more implementations of the printer. I could create an XML version. I could create another an HTML for putting it into a web page, for example, and put it into a table, a PDF printer. I could do as whatever I want, and that was all achieved by using the solid principles. So I don't know if you guys have any more questions, but this was all that I had for today. And I hope this was as useful and as entertaining for you as it was for me. of course, there are many things that can be refactored into these. There are things that still are not good in that version of the code. We can still improve it, and it's good to always be improving your code and making it more extendable. But if you have any questions now, if you have any comments, whatever, feel free to comment here, or feel free to reach to us. And remember also um, that we have our next session next week, next Tuesday. So if you haven't signed up yet, use this QR code. It will lead you to a sign up page where you can sign up for the following sessions. And also, if you haven't watched this session completely and you want to watch it from the beginning, this will be in YouTube, the same as all the other sessions that we had. So you can watch it. You can watch all the sessions as many times as you want, and the code for the solution will be pushed into a different branch called solution, so you can see that solution on your own and compare it, and you can come up with new refactorings. This is not the only solution. You can come up with your own, and you can improve it even. So if you enjoyed this, please leave a comment, reach to me. You can reach to me on YouTube or in LinkedIn, and you can reach to Globant as well. So that's all we have for today, and thank you for watching, and I'll be seeing you next Tuesday. Bye.